Alright, phase demodulation. Phase demodulation intelligence containing the amount with the rate of the phase shift the carrier wave should recover your study of the phase modulate the incident, shift the frequency of the phase of the carrier, shift the phase, cover the incidental frequency of the frequency modulator, demodulator, slash the Foster Sealy discriminator radio deflector. You also demodulate phase signals and other circuit that may be used as a gate beam quadrated the detector. Remove the remember the frequency modulated detector output determined by the phase of the signal present with the grids. A quadrated detector phase demodulation works in a similar manner. A basic command figure 319 quadratic grid signal is associated with the reference of the transmitter. They may be simply unmodulated oscillator provided with the phase reference from the detector, the carrier for the oscillator, master oscillator, the transformer capacitor, the four-way grid resistor pin, positive input, PIN input, the voltage output of the capacitor of the resistor. The modulator waveform is applied with the limiter grid with the grid action tube will actuate the phase shift of the input with the waveform of the reference. They combine output current with the weighted beam tube will be shared with the current pulse. The pulse will vary with the width, as shown figure 320. Width of these pulses will vary according to the phase difference of the carrier and the modulated wave. Pulse demodulation. In pulse demodulation, we use the radar signal well with the common signal for the discovery of the chapter 2 with the pulse modulation signal with the radio with the detector with the symbol signal with the detector with the presence of the radio frequency and with the signal with the capable with each were very for the cover the chapter with a continuous wave detection discussion. Therefore, the information will not be repeated here. The radar detector symbol waveform must be capable of producing output with the radio frequency reflected from the target that present with the input of the communication pulse detector modulated waveform from the most be restored to the original form of the chapter. Will be have three basic methods of pulse detection: peak of the low pass filter and the conversion peak detection, you with the amplitude with the pulse amplitude with the modulate with the PAM, peak of pulse ultimate amplitude modulate with the or the duration pulse duration modulate single to recharge the holding capacitor restore the original waveform. The demodulated waveform will contain some of the distortion, but with the output wave did not appear sending wave. However, the distortion did not serve enough to prevent the use of the peak detection. Peak amplitude demodulation. The peak detection with the detect peak amplitude modulation figure 321 include with the simplified circuit of VA with the demodulated waveforms VUE and C. Diode 1 is the input diode with the L of the capacitor 1 is with the peak of the value with the peak amplitude demodulation. Input pole with the peak amplitude modulation input pole shown the UCB with the conductor 1 diode 1 is reverse bias between the input pole for the detector circuit from the circuit of the diode 2 and diode 3 are based on bias where they are normally non-conductive discharge path of the capacitor through the resistor 1. These are the components shown with the time consult with the concept with at least 10 time with the input period the time between the pole with the main change for the charge of the capacitor 1 between the poles, allowing only a small discharge before the next pole is applied with the capacitor's discharge just prior to each of the impulse to allow the output voltage to the follow the peak value of the input pole for the discharge of diode 2 and diode 3 of the diodes are tuned with the negative pole for the source of the time, synchronizing the time of the pulse stream add of the transmit of the diode 3, ensure the output voltage is near zero during the discharge period of the VUC. The show of the output wave shapes of the circle of the peak of the input output signal with the loud very closely. Original modulating wave is shown with the dotted line, additional filtering with the step of the waveform with closely approximately in the original shape. Alright, this shows the circuit of the peak detector, capacitor, diode 1, capacitor 1, resistor 1, capacitor, diode 3, capacitor 3, resistor 2, and discharge pulse. The amplitude modulated pulse, the peak detector amplitude modulated pulse, the peak detector peak detection. Peak duration modulation. Peak detector circuit that may also be the view of the peak duration modulation. To determine the peak duration modulation, you must modify the view of the figure 321, the time constant charge of the capacitor 1 with the diode 1 at least 10 times the maximum received pulse width of the plane. This may be done with the identical resistor in the series of the cathode circuit of diode 1, the amplitude of the voltage of the capacitor 1 before it reaches charge. The negative pulse of the wheel is directly proportional to the input of sub-pulse width. Long pulse will also allow the capacitor 1 to charge with the high potential, then the short pulse of the charge has helped with recover the long time of the resistor 1 capacitor 1. So the discharge pulse of the end diode with capacitor diode 2 and 3 with just prior to the next incoming signal with these charges across the capacitor will result in the wave shape of the form. Some of the output shown with the pulse amplitude modulation detection VUC of the figure 321. Alright, your low-pass filter, another method of the demodulation pulse duration modulation is with low-pass filter. The voltage of the pulse waveform is average for both the pulse and no pulse time. Average voltage results of the amplitude of the pulse duration modulation pulse with the constant average voltage is directly proportional to the pulse width. The pulse with the value of the modulation intelligence. The pulse duration modulation becomes the average value of the pulse train with the varies the accordance with the modulation intelligence may be instructed passing with the modulated pulse through a low-pass filter. The component of the discharge of the filter must be selected so that the filter passes the desired modulation frequency vary with the wide width of the pulse are applied with the low pass filter. The average voltage across the filter will vary in the same way with the original modulating voltage. With the voltage varying voltage will close approximately the originally modulating voltage. Conversion, poles position, modulation, poles frequency modulation, poles code modulation, more easily modulated with the first, converting with either the poles duration, poles amplitude modulation. After conversion, these poles are modulating usually either peak detection or low pass filter. These conversions may be done with many ways by signal limited to similar methods. Poles position modulation. The Pamper covered with the pulse duration method using flip-flop circuit. The flip-flop is discovered in the Neets module 9 introduction wave drop. The wave shape of the circuit with the figure 322 show the waveforms. The conversion of the pulse position modulation, pulse duration modulation. View A, pulse modulation, pulse stream. View B is the series of the rest of the triggers. Pulse. The trigger pulses must be synchronized with the unmodulated position of the pulse. Position module pulses within the fixed time delay for these pulses. The position modulated pulses applied with the flip-flop output is driven positively shown that you see after the period of the time the trigger pulse is generated derived with the flip-flop out with the negative the pulse and because of the pulse position pulses are constantly varying in position reference if they unmodulated pulse the output of the flip-flop that also vary the duration with the pulse duration modulation signal can be applied with one of the circuits that has already been discovered the demodulation. Pulse position unmodulated conversion of the pulse position to the pulse duration method. Pulse frequency of the modulation vary with the pulse position modulation may be converted by the same method. Pulse code modulation. Pulse code can be easily decoded with the provided with the pulse code group that has been translated as if the reverse over is the pulse of the lowest value with the transmitted for the pulse over the highest value with the transmitted the left. The circuit provided with the constant value with the current without the regard of the load with the noise of the current source with the current sources. So you apply with the pulse code modulation pulse with the resistor the capacitor circuit that shows after the shown figure 323 view A the current source of the must be applied with the supplying line or charge of the capacitor. Thus increase the time of the pulse with the capacitor 1 is not allowed to the discharge between the pulse and the other words the capacitor 1 charge is about 16 volts during the period of one pulse with each of the additional pulse increases charged by 16 volts for this and the cumulative value of the increase of 16 volts each for the receiver of the pulse does not provide with the usable output unless the resistor is chosen to allow the capacitor 1 to discharge the 1/2 the value between the pulse with only one pulse to receive the transistor 1 capacitor 1 and discharge the 16 volt then just be discharged. Transformer 2 is charged with the decay with the 8 volts to continue with the decay until another pulse to receive. Transistor 3 is 4 volts discharge and the transistor 4 is only 2 volts. Sampling of the time 1 volt the charge remains the charge corresponding with the binary weighted pulse of 0001 will apply with the pen and positive pulse code modulation will correspond with the binary code equivalent to 7 volts of 10111. Figure 321, view A and view B is the pulse code of the receiver. Remember the pulse transmitted with the reverse code view C. That is the response curve of the circuit of the transistor 1 pulse corresponding to the least significant digit applied with the capacitor 1 charge for the 16 volt. The capacitor 1 discharge of the pulse until the 8 volts of the transistor 2. Transistor 2 another pulse the charge of the 24 volts. Transistor 3 the capacitor 1 discharge of the resistor 1 value with the 12 volts. The pulse of the transistor 3 increase the capacitor charge on capacitor 1 is 16 volt. The total of the charge is 28 volts. The transformer 4 with the capacitor 1 discharge of the 1/2 the value of the 14 volts. No pulse. The transistor 4 capacitor 1 will not receive the additional charge of the capacitor 1 continue the discharge of the transformer 5 but it will reach the 7 volts amplified sampled with the provided pulse amplitude modulation pulse which can be peaked and sampled out with the corresponding original sampling analog voltage over the modulation. Alright, pulse group the input with the resistor 1 capacitor, output amplitude pulse the sampling time, the resistor converted with the positive code multiplication and code modulation to positive pulse amplitude modulation. Sampling time, transformer, binary pulse code equivalent analog 7 in reverse order. Positive code modulation to modulator recognizes the presence of the absence of the pulse in each position. Reduce the correct standard amplitude represented with the pulse code group. The retrieve the noise, introduce the no error. Largest peak with the noise, do not mistake with the pulse. The positive code modulation signal can be retransmitted many times with the desire without introducing additional noise effect. So long as the signal to noise ratio is maintained level of the noise pulse with not mistake with the signal pulse. This is not only method of the demodulating pulse of the pulse code modulation, but is only one of the simplest. Alright, this completes your study of the demodulation. You should remember that the modulation has been basic introduction principle of modulation, demodulation event with a solid state electrical integrated circuit that play for the discrete with the components also that cannot trace the signal through the circuit that ends with the result electronic action integrated circuit that is the same would be the discrete components. Alright, and then that's chapter 3 summary. I have to reread chapter 3 part 1.